Okay, in this video we are going to simulate a series circuit using a variable resistor and a potentiometer. For some reason they have two different symbols for it or icons for it, so to avoid any confusions I'll do both of them. So to start, we are going to go insert our ground. We always need a ground, and we're actually going to do the two different ones, so we need two grounds. And then I need my DC source, power source. So I'm gonna do two because we need two circuits for comparison. And then I'm going to go and go to the basic family. And then from the basic, I'm going to pull some resistors so that you can see how it connects when there is more than a single resistor there, and then you can expand the idea. So I'm gonna pull 1 5 and another 5. Okay, right there. Then I'm going to go into the variable resistor. This icon is interesting because it only has two terminals, and then you just change the percentage here. So this is interesting. It's not what we usually find in the real world. And then we have a potentiometer. So this is what we are used to see in the real world. So this resistor, let me flip it 90 degrees. So this resistor right here, it only has two terminals. So this is pretty straightforward. We usually don't have these resistors in the real world. So design wise, probably it makes it cleaner. So this is a percentage of what, this is the total. So the potentiometer goes from 0 to a total of 10,000 ohms. So if we have a 50%, that means this value, it is 50% of the 10,000. So that's 5,000 ohms. And then this other one, which is what we usually see in the real world, it has a little trick to it. Okay, so then this goes connected to that terminal, and then we close the circuit with the middle terminal. Okay, so the circuit gets closed with this bearing arrow that goes from, let's change this value to be 10,000 too. So let's make that value to be 10,000 ohms. And then the third terminal of the resistor, we are going to connect it to ground. We need to connect the source to ground as well. So the source gets connected to, hold on. Let me delete that. I'm going to connect the source to ground. Okay. And then this gets connected to ground as well. Okay. So there it goes. So I have a regular resistor connected to a two-terminal variable resistor, and I have a regular resistor connected to a potentiometer. This is what we usually see. It has three different connections. So then we can pull our multimeter and calculate the current going through this. Let me not put it there. I'll put it right here better. I'm just gonna pull this way. And then I'm gonna connect it right here. I'm gonna get rid of that. Now I'm going to simulate this. And my volt is 12 volts. No, that's wrong. My current, let me see. I have to, what is my current? my current, let's do the Ohm's law to see. I have 12 volts divided by 5,000 plus 5,000 because this is a 50%, so it's divided by 10,000. My current should be 1.2 milliamps. So it's right? If I change this, let's change this to 70%. So if I have 10,000 times 70%, now I have 7,000, excuse me, plus 5,000, now I have 12,000 ohms. So if I redo this, now my current is going to be, this doesn't make sense because how current can go higher, right? So 12 divided by 12,000 should be 1 milliamp. So there is something wrong here. My multimeter wasn't working to start with. Let me get rid of it and let's use the probes because for some reason it's not giving me the right readings. Delete. Oops, I cannot delete because it's running. So stop. Stop the running. Let's run it again and see what it says now. Yeah, that's wrong. It should be 1. So let's stop it. Let me get rid of this. Let me connect this. Okay. Hopefully your multimeter is working. So if I put the probe there and I simulate, okay, hold on. Simulate. Let me stop it. Okay, analysis, DC operating point, probes only. So I'll say run. Okay, what is it that I'm getting? I'm getting the same reading. Let me see what's happening. Okay, so I find out how they have it connected here. So this 70%, it's actually 70% of not use. So it's backwards. It doesn't mean 10,000 times 70%. It means only 30% of the 10,000 is actually used. That's why we actually went from 5,000 ohms to measure, let's measure the resistor across this value. So this resistor, for some reason my multimeter doesn't read the resistor. It should read that we only have 3,000 resistor here because let me get rid of this. Maybe that's why it's not doing it. But besides the point, if we measure the current, let me get rid of those things here. We get the 1.5, right? So if I were to put it here and here, our readings, if I play that, my reading would be, okay, I don't need that. So if I read that, let me run it. Okay, it's because I'm doing the probes and I don't have a probe. So I do all variables and then I run add expressions. So I'm just gonna add the current. Okay, and then I'm gonna say add, and then okay, for some reason now it's not reading it. Let me get rid of that and use the probes just to make it easier for everybody. Okay, so if I put it here, now I should be reading 1.5, right? So if I put it there, I should be reading 1.5 in the as my current. So let me go ahead and fix that so we only see one instead of everything. So props, and that's the only prop we have. Actually, we have more props, so analysis, we have remove, remove, and remove. Okay, so this is my only prop that I want to add, and that's it. Okay, so you see, now we have 5,000 and 30% of this resistor, which is going to be 3,000, so we have 8,000. So we have 12 volts divided by 8,000, we have 1.5 milliamps. If I slide this to 30%, now I should get 1 milliamp, you see? So that's how you will read it. It's backwards. So if you want to use, let's say, 1,000 ohms, you wouldn't go to 10% because 10% would mean that you're using 9,000. So you will have 9,000 plus 5,000, you'll have 14,000. So 12 divided by 14,000, you'll have 8.57 times 10 to the 4. If we do it, they're going to give it to us in micros. Yeah, so they'll give us 857 microamps. So it's backwards. So if you want to say that you have 6,000, so you will have to put it at 90%. So now you have 12 volts divided by 6,000. That's going to give you 2 milliamps. And see, if we play this again, that gives you 2 milliamps. So that's how this potentiometer works, okay? Now, if we go to this other resistor, which I don't recommend you using, I want you to use this one, but if you did it before I said it, then you can do it here. So here we have 10,000, so this should be 1.2 milliamps. If I change this to 70%, then this one, let's see how it works. It should be 1. If I run this, it should go to 1 milliamp, and it does. So this one is linear, okay? This one is straightforward. So if I change it to 90, means I have 14,000. So if I have 14,000, I should get 857 microamps. So that does it. If I want to have 6,000, I take this to 10, and that should give me 2 milliamps. So that's how you will work it. Okay? Hope that helps in answers all the questions.